Hello and welcome to another INB382 demo video, and this time it's about Gooch shading. As I mentioned in the lecture, this is a non-photorealistic form of shading which takes any lighting model that is used in a scene and maps the luminance to a gradient between hot and cold colours and particular base tones. And so this enables us to have a visualization that shows shape with something sort of pseudo-realistic and enables us to use different base colours to identify different shapes with these colours. So I won't go so much into the theory in this video, but just to show you, here's the teapot that has been created, and we have our, it's just sitting there looking very Gooch coloured. So we have the warm orange colour going to a cold blue with a gradient in between following the light source. You can see a specular component there. I've also added in, because Gooch sort of allows for the fact that the idea is to highlight edges in order to further show structure. So I've left in here the edge detecting method from the cell shader. And as you can see there, this just provides us with a demo of how the Gooch shader works. So probably works better with much more complex geometry, but we can still see here that we have a sense of how objects are situated in this space and how they relate to each other by the shading, and the coloration gives us an idea of curvature while sort of holding out a model of lighting in the scene. So it's a sort of sweet spot between these concepts. Wrong click. So if we go over to the shader here, it's not a particularly complex shader. We see there's some various parts here, but what we note as well is that we have a light color and a dark color. So the basis for the basis of the coloration of the object, but the cool color and the warm color, which is mixed in order to create this Gooch shading style. The vertex shader, straightforward. There's just a normal and world coordinates, position and world coordinates, and the view position in world coordinates, so the view location, and the light vector, light position, and the world coordinates subtracted from it. So that's straightforward. And then in the pixel shader, we see here that, first of all, we calculate an edge value here. All that is to do is to enable us to show the outline, which supports the identification of structure in the scene. And then what we have down here is probably where most of the work occurs. So we've got down here the code that does the tone mapping. And we see here that we got a light value from just ln dot product between them. So all the normal things that are done inside of a diffuse shader. And then using these linear interpolations here between the dark and light color, the mixer, of course, is based upon this light value. And what we end up doing is, so instead of it being from 0 to 1, it's actually multiplied by half and then add 1. So it's scaled appropriately to suit the diffuse linear interpolation we require here. And so using that mixer we've computed and a standard sort of diffuse component here, we end up mixing between the dark color and the light color, the cool color and the warm color. And this implements Gooch's ideas around tone and warmth and so forth. And once this is again mixed together, we end up with, so our diffuse contribution is the surface color here plus an actual tone color mixed together. That gives us this orange appearance that we see. But the cool and warm colors are also mixed over the dark and light colors in order to bring out the encoding. Mixing that together, of course, with the edge component, a la cell shader, we end up with this Gooch shading appearance. So while that may not seem so amazing, it's still a non-photorealistic method which enables you to show the shape of things inside of technical diagrams. So this sort of coloration you would often see inside of engineering manuals. If you want to provide some sort of structure relative to a light source, which is amenable to human perception, but using false coloration so you can show the shape more clearly, and also to be able to then map different colors to different objects using dark and light colors so that we can identify them inside a large complex engineering diagram. So this is probably a more non-game shader, but still something useful to have in the bag of tricks nonetheless. Okay, that's the end of the video. Thank you very much for listening.